Hello friends, today we are going to discuss about the protection of thyristor circuits. Whenever a circuit or an electric circuit consists of thyristor and the thyristor is allowing the flow of electric current through it, it is very important we as an engineer take care of the protection of thyristor circuit. Let's say, what are the problems when a thyristor is implemented in an electric circuit? So friends, here there are various kind of protections that is needed whenever a thyristor is being used in an electronic or electric circuit. So here, let's talk about di by dt protection. So friends, as the name specifies, di by dt is the rate of change of current per time. So what happens is that whenever an inductive load is connected with the circuit or due to some other circumstances, the rate of change of electric current across the circuit reaches to a very high level. Because of that, the thyristor gets triggered and it starts conducting the flow of electric current, which is very dangerous. So for us, it is very important we have to use a protection element or a protection circuit to limit the flow of electric current through the thyristor. And the entire protection circuit is called a snubber circuit. So we will be talking about snubber circuit, which is being used to protect the thyristor circuits in depth. So here friends, this is called snubber circuit. So you all can see this is the thyristor and I have connected an inductor in series with the thyristor. Though the job of an inductor is to limit the flow of electric current or to limit or to restrict a sudden rise of electric current. Whenever di by dt is extremely high or there is a sudden rise of electric current or an impulse of electric current, the job of an inductor is to limit the current, or it does not allow or it restricts the flow of electric current through it or a sudden change of electric current through it. Now friends, let's talk about the other mode of operation of electric. So friends, let's talk about di by dt protection of a thyristor. Whenever a thyristor is connected in an electrical circuit, because of some inductive nature of the load or due to some other unfavorable circumstances, there is a sudden rise of electric current in a very small amount of time, which increases the value of di by dt and it allows the thyristor to conduct because the gate gets triggered. So it is very important for us to limit or restrict a sudden rise of electric current. So here, in this circuit diagram, I have drawn a circuit which is called a snubber circuit. So remember friends, snubber circuit is used for the protection of thyristor or the protection of devices which consist of thyristor. Here, what I have done is, I have connected an inductor in series with the thyristor. What an inductor does is that it restricts a sudden change of electric current, or in other words, it allows or it does not allow a sudden change of electric current through it, and it limits the electric current, which in other words, it never allows an exceeding value or a sudden exceeding value of di by dt so that the thyristor cannot get damaged. What if there is a sudden rise of electric current or di by dt is extremely high in a thyristor? In that case, the thyristor might get damaged and the entire equipment might get damaged because it leads to an unintended flow of electric current through the thyristor or an unintended triggering of the gate circuit of the thyristor. Now friends, we can reduce or we can protect the thyristor against di by dt by using a snubber circuit, especially by using this inductor in series with the. Now friends, let's talk about what is dv by dt protection. So we can easily protect the thyristor circuit using a di by dt protection circuit or an inductor in series so that it restricts the sudden change of electric current. What if there is a sudden rise of electric voltage in a very small amount of time. This leads to an extremely high rise of dV by dt. So whenever, due to some circumstances, dV by dt, rate of voltage with respect to time, increases to a very extreme level, at that point of time, we have to use a resistor and a capacitor in parallel with the thyristor, so that whenever there is a sudden rise of electric voltage, the capacitor takes up the voltage, or in other words, the capacitor gets charged and it protects the thyristor. So this is called dV by dt protection, and the circuit which consists of a di by dt protection, which is an inductor in series, and a RC circuit, or a resistance and a capacitance in parallel, is called a snubber circuit. So friends, here we can easily calculate the value of the inductance, the capacitance, and the resistance. So we exactly know what is the value of the inductor, the capacitor, and the resistor, which is being used, or which should be used, to protect the thyristor and to construct a snubber circuit. Here you can see the inductance L is calculated from the thyristor for safe di by dt, which is the maximum value. Now, to calculate the inductance value, or to calculate the value of inductor, we need to keep in mind what is the maximum rise in di by dt, so that we can calculate an extremely high value of inductor, so that the circuit is always safe. Now, here, if we apply the same method, we get to this result: L is equal to V max divided by di by dt max, because V max will be equal to L di by dt max. So here, V max will be equal to L di by dt max, L into di by dt max, and L becomes V max divided by di by dt of maximum value. Now, let's say the value of R and C, the resistance and capacitance, for the snubber circuit can easily be calculated with this method. Say dV by dt maximum is equal to V max, which is the applied maximum value of the voltage, into R divided by L, where R is the resistance, L is the inductance. So if we solve this, we get the value of R, which is equal to 2D under root inductance divided by capacitance, where D is called damping factor. Now friends, if we use the value of R and L in the earlier equation and solve the same, it becomes dV by dt max is equal to V max into 2D under root inductance divided by capacitance into 1 divided by L, where L is the inductance. And if we solve this equation, say this is equation 1. If we solve this equation, the final value of capacitance, which comes out to be this: C is equal to, in bracket, 2 into V max into D divided by dV by dt max whole square into 1 divided by L. So friends, if I summarize, there are two methods to protect the thyristor circuit. One is di by dt protection, and number two is dV by dt protection, and both can be done by using snubber circuit and calculating the right value of the inductance, resistance, and capacitance. Thank you friends for watching this video. Please subscribe and stay tuned with Ekeeda. Thank you so much.